Namaste and hello to all of you. Welcome back to my YouTube channel. I am 𝐶𝐤 𝐭𝐻 and I have started this series of lectures in which I am solving all the back questions from R.K. Bali. Keeping in mind the importance of the R.K. Bali questions, solving these questions will help a student's preparation, boost his confidence and make him fully prepared for the DGCA exam. Convergence is another chapter that is often asked in DGCA exam. The importance of convergency questions cannot be overemphasized, and therefore I have decided to do convergency questions from R.K. Bali as well as Oxford. I have already done the Oxford questions from convergency chapter and have uploaded that video in my channel. So do check out that video and also solve the questions from this convergency chapter from this video. So today's topic will be convergency from R.K. Bali. So let's start with question number 23. So question number 23 from R.K. Bali chapter, convergency. The questions before question 23 are all solved questions. So you should not have any, you don't need any explanation or solution for that questions as such. In case you need any help or you need any clarity, you can obviously contact me or let me know in the comment box. I will reach out to you personally and solve your doubts. To begin with question 23, the angle between the true great circle track and the true Rhumb line track. Okay, so the angle between the true great circle track and the true Rhumb line track they are talking about. So that angle between true great circle and true Rhumb line is called convergency angle. So in other words, they are talking about convergency angle. So they have given us the coordinates. One is at 165 west and other is at 177 east, 177 degree east. Okay. At place of departure A is how much? So let's plot this diagram. Now whenever we are talking about longitudes, both are located at same latitude and different longitudes. That means there will be a Rhumb line joining them. So this is your Earth. Whenever we want to draw a diagram of longitude, I have always told you to do a diagram like this for longitudes. This is your North Pole. You are looking at the Earth from the North Pole. This is your 0 degree equator. This is your 180 East Hemisphere, West Hemisphere, 90 East and 90 West. So A is at 165 degree West. A is at 165 degree West. B is at 177 East. B is at 177 East. Next, you're going from A to B at the place of departure. So A to B will be what direction? It will be a westerly direction. It will be a westerly direction. All clockwise directions are westerly. All anti-clockwise directions are easterly. So let's draw this. There is position A somewhere here. This position B. Those two longitudes are here. They both are in the southern hemisphere. So it will be somewhat like this. This is your great circle. This is your Rhumb line. Now we know the angle from A to B Rhumb line track is 270. Rhumb line track is 270. Okay, Rhumb line track A to B is 270. Because both are located at same latitude 60 degree north, 60 degree north. So the directions will be easterly and westerly. Rhumb line from B to A will be opposite of 270, which is 090. which is 0, 9, 0. Now to find convergency angle, which is the angle between this Rhumb line and great circle. The angle between Rhumb line and great circle. Let's find out convergency. Convergency is d long in degrees into sine latitude. So the difference between these two longitude is how much? 180 minus 165 is how much? 15 degrees. 180 minus 177 is how much? 3 degrees. So total d long will be 18 degree. So 18 degree into sine of 60. So 15.5 degrees. 15.58 degrees. Convergency angle is half of convergency. So half of 15.58 degree, that is equal to approximately 7.79 degrees. 7.79 degrees. Okay. So now in this case the correct answer will be 7.8, option number C. Okay, direct. So just find convergency from the given coordinates, find convergency angle. Just for your understanding and for better concept clarity, I have drawn the two coordinates. I have shown you how to draw it in the diagram like this. Then I showed that we are going from A to B, which is westerly direction. That's why A was to this side and B was that side. Okay, and A to B is 270. B to A Rhumb line is 090. The convergency angle is how much? 8 degrees. 8 and 8. Now it is your homework. I'm giving you homework to find out great circle track from B to A and great circle track from A to B. Very simple. You have Rhumb line tracks at both places and you also have convergency angle at both places. So find out great circle from B to A and A to B. Let's go on to the next question. Question 24. The average true course of the great circle is 100. The true course of the Rhumb line at point A will be how much? Now they are saying about average great circle. So the average great circle direction is 100. What will be the Rhumb line direction? So remember, whenever we draw a great circle and Rhumb line, let's say we are in the northern hemisphere. So the great circle will pass from the north pole and come down to the point B. Now we know this is your Rhumb line, this is your great circle. Now the great circle direction at A, okay, great circle at A will be different from great circle at B, right? We know that the great circle direction is always changing as opposed to Rhumb line direction, which is a constant direction line. So between these 2 points, between this angle at the beginning and the angle at the end, at the destination, there will be an angle made here, somewhere here, where there is a parallel line. This line, okay, at this particular point on the top of the great circle track, that point is parallel to the Rhumb line. Okay, somewhere at that small point. And therefore, this Rhumb line direction will be equal to the direction at this particular point. At this particular point, which is parallel to the Rhumb line track. Okay, so if Rhumb line direction is 090, somewhere here the direction will also be 090 at that particular point at that particular place. Now when they talk about average great circle track, so average great circle track means the average of these two angles. Okay, average of these two extreme angles, which will be found somewhere in the middle of the track, and this middle position is parallel to the Rhumb line position. Therefore, when they talk about great circle track, the average great circle track, they are indirectly telling us about Rhumb line direction. They are indirectly telling us about Rhumb line direction. So the correct answer here will be average true course of the great circle is 100. So that means Rhumb line direction will also be 100. Okay. Let's go to question 25. What is the formula for convergency? Convergency equals D lat. Convergency equals D lat. Convergency equals d long into sine of mean latitude. So correct option will be option Charlie. Convergency is a phenomenon which is associated with longitudes or meridians of longitude. Okay, latitudes. So over here, you know that on the earth we have meridians converging at North Pole and South Pole. We have meridians converging at North Pole and South Pole. But in case of latitude, what do we observe in case of latitude? Latitudes do not converge with each other or one another. Okay, so latitudes are equally spaced lines. But meridians of longitude are not equally spaced lines. They converge with one another at North Pole and South Pole. Okay, so that's why the formula of convergency includes d long, difference between two longitudes, into sine of latitude. Next, so that's why we have eliminated option A and B, because latitude is not a convergency phenomenon, or it's not related to convergency in any way. Aircraft passes position A to B, so it's going from A and landing at B. What is the great circle track from A? Very simple. So let's plot these positions. One is at 120 west, another is at 140 degree 30 minutes west. So this is your Earth. Like always, we have the North Pole, prime meridian, 90 east, 90 west, 180 east and west. So the first 120 degree west will be somewhere here, and 140 degree 30 minutes west. Okay, so A is 120 west, B is 140 degree 30 minutes west, and you are flying from A to B. So what direction is this? This is a clockwise direction. So the direction of your flight is A to B, westerly direction. It is westerly direction. So A to B, westerly direction, both are at same latitude. That means a Rhumb line track A to B will be 270, and we are in the north hemisphere. So Rhumb line track A to B 270, Rhumb line track B to A, opposite of that 090. Okay, A to B is 270, B to A will be reciprocal of that 090. Now let's find convergency. Convergency is d long into sine lat. The difference between these two longitudes, same hemisphere, subtract. So 140 minus 120 is 19 degree 30 minutes into sine of 60. So convergency will be equal to 16 degree 53 minutes. Convergency angle will be half of that, which is equal to 8 degree 26 minutes. So let's consider this 8 degree only. Okay, now we have to find great circle track. Great circle track from A to B. Great circle track from A to B. So yeah, A to B. So Rhumb line track at A to B is 0270. Great circle track A to B will be Rhumb line track plus convergency angle. You can see great circle is to the right of Rhumb line. This is your great circle. This is your Rhumb line. Now when we go to the right hand side of something or clockwise directions, the directions increase. So if A to B Rhumb line up to this point is 270, to reach great circle we have to move up additionally by 8 degrees. Therefore great circle will be more than Rhumb line by a difference of 8 degrees. or as you can see, great circle is to the right of rhumb line. That means great circle direction will be more than rhumb line direction by the difference between them, which is 8 degree. So great circle A to B equals to 270 plus 8. So great circle A to B will be equal to 278 degrees. 278 degrees. Okay. So this is how you do it. Approximately Charlie. 279 degree. Okay, the closest option. So plot the diagram, determine the direction in which you will be flying if you start from A and go to B. Okay, so when we find out that A to B is 270 direction, we can draw another diagram like this. Labeling that diagram, A to B a rhumb line direction of 270, B to A reciprocal 090, find convergency, get convergency angle, okay, and then great circle A to B is simple to find. Then rhumb line plus convergency will give you the great circle. Now as a homework you will have to find the great circle B to A and let me know the answer. Great circle B to A. Let's go to next question, question 27. A great circle track joins A and B. What's the difference between great circle track at A and great circle track at B? So, the difference, convergency. Now, the definition of convergency is that the angle between two meridians at a particular longitude, a particular latitude. But convergency also means that the difference between two great circle tracks, the difference between two great circle tracks is also called convergency. So there are two definitions. Now here we want to find out the difference between the great circle track at A at origin and great circle track at B at destination. So the difference between them will be the convergency. Now you all know the DIID diagram. When you are in the northern hemisphere and you are in the southern hemisphere. That means traveling eastwards, traveling in easterly direction, your great circle track increases. Traveling in the westerly direction, your great circle track decreases in the northern hemisphere. In the southern hemisphere, traveling in easterly direction will result in decrease in great circle track. Traveling in westerly direction will produce an increase or increment in great circle track. Okay. Now in this case, you are in the southern hemisphere. So you are in the southern hemisphere. And then the points given to you are 141 west and 148 west, approximate same latitudes. So you're going from 141 to 148. So on the earth, 141 west longitude will be somewhere here, let's say. So 148 longitude will be to the west of it. So it will be to the west of it. So that means you're going from 141 west to 148 west. You're going from 141 west to 148 west as given in the question. Indirectly you're flying to in the westerly direction. You're flying westerly direction or to flying a heading of 270. Okay, or in that range. Now when you are in the southern hemisphere like in this question and you are flying in the direction of west, the difference between great circle tracks will increase. You are in the southern hemisphere and you are going in the westerly direction, so your great circle track will increase. Okay, now over here, so the correct option will be either option A or option B, 3 degree or 6 degrees. Okay, so first clue was that the great circle track is going to increase. That's for sure. Now let's find out by what value will it increase. Like I said here, the great circle track difference will be equal to convergency. So let's find convergency, and that particular value will be the value by which your great circle tracks and A and B will differ from each other. So great circle convergency equals to d long into sin lat. D long is how much? 148 minus 141 is 7, sin 61 and sin 59. So the mean of that is what? Mean of 59 degree and 61 is 59 plus 61 divided by 2. So that is 60 degree. So 7 degree into sin 60 is equal to 6 degrees. So convergence is 6 degrees. So correct option will be option number Charlie. The great circle tracks at A and B will differ by a value of 6 degree. This value is nothing but your convergency. Okay. So we started with the DIID diagram. In the northern hemisphere, okay, flying easterly direction, your great circle track increases. Flying westerly direction, your great circle track decreases. In the southern hemisphere, flying in the westerly direction, your great circle track increases. Flying in the easterly direction, your great circle track decreases. In the question, we are located in the southern hemisphere. So just focus on the southern hemisphere part of this entire diagram that I have drawn separately. Label it, okay, and now we have been given two longitudes, longitude A and longitude B. We are going from longitude A to longitude B, and as you can clearly see, flying from 141 west towards 148 west, you will be flying a heading of westerly heading, okay, in the direction of west, and therefore southern hemisphere flying west, your great circle track should increase. Okay, so if great circle track at over here at 141 west uh, is let's say 170, reaching 148 west, it will increase to something else, but it will increase it. Maybe it may become 210, any value more than 170. So that increment is nothing but your convergency by definition. Let's go to next question, question 28. The Rhumb line track between two positions is approximately how much? Now we have been given location A at 45 degree north, location B at 48 degree 30 minutes north. 48 degree 30 minutes north. So let's draw two longitudes. A is at 10 west, B is at 15 degree west. A is at 45 north, B is at 48 degree 30 minutes north. 48 degree 30 minutes north. You have to go from A to B. So A to B is this. The great circle track will be somewhat like this. Okay. The great circle track will be somewhat like this. Now here we have got a triangle. Okay. We have got a triangle. Now going from this particular sum will be solved in a different manner. Just pay attention, it's simple. Going from A, this is your A, this is your B. So the latitude of A here will be the same latitude here, 45 north. Okay. Now going from A to B, we are going in what direction? We are going in westerly direction. Just this. This part of the triangle will be how much? It will be 270. Okay, if you want to fly straight between these two longitudes by following a straight constant direction track, in other words, a Rhumb line track of this triangle, you will fly straight 270 and you will reach the other longitude, which is 15 degree west. Okay, so let's find the Rhumb line distance. The Rhumb line distance will be how much? Rhumb line distance will be this much. So Rhumb line distance is d long in minutes into cos latitude. So the Rhumb line distance of this side of the triangle. Forget this Rhumb line and great circle. Let's focus on this triangle. So what is d long? 15 degree minus 10 degree, which is 5 degree, into 60. Convert that into minutes into cos of latitude 45. So 5 into 60 into cos 45 is 212 nautical miles. So this Rhumb line distance is 212 nautical miles. Now let's find this great circle distance between these two latitudes, and this will give us the measurement of this side of the triangle. The measurement of this side of the triangle is 212. Let's find that side of the triangle. Now great circle distance equals to d lat into 60. Difference between those two latitudes is 48 degree. 30 minutes minus 45 degree, 3 degree 30 minutes into 60 equals to how much? 210 nautical miles. 210 nautical miles. 210 nautical miles. And now we have this right angle triangle, and then we have this particular extra angle. So this angle is 270. Let's find this angle. Now using a trigonometric function. So we have opposite and adjacent, right? We have, this will be the hypotenuse side, the side opposite to 90 degrees hypotenuse, and that will be opposite side of this angle, and this side will be the adjacent side of this angle. So using tan theta formula, tan theta equals to opposite upon adjacent. What is the opposite side? Equal to 210. The adjacent side is 212. So 210 divided by 212 equals to 0.9er. So theta is equal to, that particular angle theta will be equal to how much? Tan inverse 0.99, which is equal to shift tan inverse 0.99 is equal to 44 degree 47 minutes. So this particular angle is 47 minutes. 44 degree 47 minutes. Now we have been told to find the Rhumb line track between A and B. Now as you can see, the Rhumb line track between A and B, which is this Rhumb line track, okay, pay attention. This particular Rhumb line track between A and B is made of two parts. It is made of, Rhumb line A to B is made of two parts. First, this angle 270 up to this side of the triangle, and plus the extra part, which is theta. So this is 270 plus this angle. So total angle will be a combination of them, this plus this. So 270 plus theta, which is 44 degree 47 minutes. Okay, so this Rhumb line direction between A and B is made of this 270 and this theta. So two parts. So 270 plus 44 is equal to 314 degree 47 minutes. So Rhumb line A to B is 314 degree 47 minutes. So approximately option number bravo. Option number bravo. Okay. This is how you do the sum, little bit tricky, but very simple. So a quick recap. We have plotted the points given to us. Draw the two longitudes. Okay. Draw the two latitudes, two longitudes, two latitudes. Then we have joined them using a Rhumb line track, and the great circle passes through the nearest pole. After drawing that, we have completed this triangle. We have completed the drawing of this triangle by drawing this side of the triangle. So we get a triangle, and then we have focused our attention completely to that triangle. Okay, we know that the difference between two longitudes will give us Rhumb line distance. So we got this side of the triangle 212 miles. The distance between two latitudes will give us great circle distance. So we were able to find the measurement of that side of the triangle. Now we have two sides of the triangle known to us. With that information, we can find out the angle, which is theta. And we use trigonometric function tan because tan equals to opposite upon adjacent. Substitute the values appropriately, find the angle. Okay, and then as you can see from the diagram, the Rhumb line track is a combination of this 270 plus this extra angle, which is a total of 314. This particular example is unique, other examples are similar. Okay, so practice this question properly, okay, till you get it perfectly right on your own without any external help. Great circle from P to Q, question 29. Great circle from P to Q measured at P is 0, 9 or 5. Conversion angle is 7 degrees. They are in the south hemisphere. What is the Rhumb line track? Simple. They are in the southern hemisphere. That means your diagram will be somewhat like this. The great circle passing down. P will be on this side, Q will be on this side because considering this your northern direction, easterly will be that direction. So P to Q is 0, 9 or 5. Convergency angle is 7. So Rhumb line P to Q. Now Rhumb line P to Q is only a smaller part of the angle, which is only this much. Now this angle Rhumb line is bigger angle great circle P to Q minus this inside angle. So Rhumb line P to Q is great circle from P to Q minus convergency angle. So great circle P to Q is 0, 9 or 5 minus 7, which is 88 degree. So correct option is option A. 0, 9 or 5 minus 7, 88 degrees. Great circle track X to Y measured at X is 319. Great circle track at Y is 325. So let's say we are in the southern hemisphere. X to Y 319325. So now when we start at X, okay, our great circle is 319. When we come towards Y at Y destination, our great circle track direction will change and becomes 325. As we all know by definition, the direction of a great circle track keeps changing, unlike Rhumb line track. Okay, so great circle track at X, that is X to Y, will be 319 as given in the question. Great circle track at Y, when you reach Y, it becomes 325. Now when you land at Y, you will drop the passengers there, pick up new passengers, refuel your plane, and then again you will turn back and fly Y to X. So great circle Y to X is how much? The reciprocal of great circle at Y. Reciprocal of great circle at Y, which is minus 180. So 325 minus 180 is 145. 145. Great circle y to x is 145 degree. So understand this. Going x to y, direction was 319. Coming back from y to x, you will fly a reciprocal direction. That reciprocal direction will be of the direction, the final direction at great circle y, which was 325. So find the reciprocal of that. So coming back, we will fly the reciprocal direction of that track. So you will start with 145 and then changing that direction, you will come to x. So the answers tells us the great circle at x is 319, at y 325. Consider the following statements. Now, first, let's find the hemisphere we are in, whether it's southern or northern. Now, when the difference between two great circle tracks, the difference between two great circle tracks is more than 180, we are in the northern hemisphere. When the difference between two great circle tracks is less than 180, the points are located in the southern hemisphere. Okay, now let's find the difference between these two great circle tracks at x to y and y to x. So the difference between them is how much? 319 minus 145. So it is 174 degree, which is obviously less than 180 degree. So that means the points are located in the southern hemisphere. The points are located in the southern hemisphere. Okay. So the eliminate option B. Now probable options are A and C. Now they are asking you to find Rhumb line track. One is 331, one is 322. Okay. Now the difference between two great circle tracks is your convergency. So the great circle track at X was 319, at Y was 325. Okay, so the great circle track has changed from 319 to 325. So that means this has happened due to the convergency of meridians. So convergency in this case 325 minus 319 is how much? 6 degree. So convergency angle will be 3 degrees, right? 3 degrees. So now the Rhumb line track in either case will be how much? So Rhumb line track will be how much? So the convergency angle is the angle between a great circle and your Rhumb line, right? Now let's take consider great circle 319. So 319 plus 3 is how much? 320, 321, 322. Okay, so the difference between Rhumb line and great circle is your convergency angle. Out of this we have been given, out of this we have been given, out of this we have been given what? Great circle 319. We have found convergency angle 3 degree. So Rhumb line will be the difference between great circle and convergency angle. 319 plus 3 is 322, or 325 minus 3 is again 322. So the correct option is option number C. The correct option is option number C. 331 is a very big Rhumb line track. So to get 331, the convergency angle should be 325 plus something, 319 plus something. So that is not possible. So convergency angle 3 degree. We can calculate 322 from both 319 as well as 325. So it satisfies both conditions. So option Charlie is the correct answer. So how to find? Let's a quick recap to find the hemisphere. Okay. Great circle x to y is given to you. Find great circle y to x. Reciprocal of great circle at y. Okay, so with that, if the difference is more than 180, you are in north hemisphere. If the difference is less than 180, you are in the south hemisphere. And then to find the Rhumb line track, you should know the convergency. By definition, convergency is the difference between two great circle tracks. Therefore, you can also calculate convergency angle. Okay, and That is how we have got 322. Question 31. One place is at 70 south 60 west, another is at 70 south 30 east. What is the initial great circle track? So both are at same longitudes. So one is at 60 west, one is in the other hemisphere 30 east, and we are in the south. A to B. So A to B, going from A to B, we will be flying what Rhumb line track? We will be flying a Rhumb line track of easterly direction, which is 090. Now we have been told to find great circle track. Great circle track from A to B. Now definitely great circle track from A to B will be Rhumb line track A to B plus convergency angle, okay, plus this plus this small convergency angle, right? So definitely great circle track from A to B this will be more than 090 by some convergency angle, more than 090 by some convergency angle. Now definitely all these values are more than 090, but you can see 270 and 312 are two big angles. Okay, too big to be possible. 132 is an angle which is somewhat closer to 090, the closest of all three. Okay, so without doing the calculation, we can know that option B is the correct option. But just for the sake of practice, let's find out convergency. Convergency is d long in degree into sine lat. So convergency is 60 west and 30 east. So different hemispheres add. So d log 60 plus 30 is 90 into sine of 70, which is 90 into sine 70 is 84 and a half. So convergency angle will be half of that, which is 42.2, approximately 40 degree. So great circle A to B equals to how much? Rhumb line A to B plus 40, which is 130. So option B is the correct option, the closest option. Okay. Now let's go to the last question for the day. Great circle track from A to B is 242. So let's draw this. One is at 10 degree west, another is at 40 degree west, and we are in the southern hemisphere. So A to B. So great circle A to B is given to you is 242. Great circle A to B is 242. What is Rhumb line from B to A? What is Rhumb line from B to A? This part. So to find Rhumb line from B to A, we will find first Rhumb line from A to B. Now, if we know Rhumb line from A to B, it will be easy to find Rhumb line B to A. Okay. Simple words, Rhumb line B to A will be reciprocal of A to B. So let's find this. Rhumb line B to A is equal to how much? So Rhumb line A to B, let's find this equals to. Now Rhumb line A to B is nothing but the right of great circle track. So it will be more than the great circle direction by this convergency angle. So Rhumb line A to B is nothing but great circle A to B plus convergency angle. Now what is great circle A to B? It is 242. What is convergency angle? We don't know. Let's find out convergency. So convergence equals to d long in degrees. So what is d long? 40 west minus 10 west 30 degree into sine of latitude. What is the latitude? 25 south and 35 south. So the mean latitude will be 25 plus 35 divided by 2, which is 30 degree. So mean of these two latitude is 30. So sine 30. So 30 degree into sine 30 is half. So convergence is 15 degrees. Convergency angle will be 7.5 degrees. So let's substitute the value here. 242 plus 7.5, which is equal to 249 degree 5 minutes. So correct option is option A. 249 degree 5 minutes. Okay. So that is rhumb line A to B. Correction. We have to find rhumb line B to A. So rhumb line B to A will be reciprocal of, even in exam, don't do the mistake that I have done now. Reciprocal of 249 degree 5 minutes. So 249 minus 180, 69 degree 5 minutes. Okay. So look at the question, pay attention and double check the answer. So correct option will be option Charlie and not option A. So even you can repeat, do this mistake in exam in haste, impatience, hurry. So make sure that you read the question. After solving the entire question, read the question again and double check your solution. Okay, to verify your final answer. So A to B was 249. We were asked to find B to A. So B to A will be reciprocal of A to B. And that's how we got 69.5. With this, we have come to the end of this lecture. I hope you have understood this lecture very well. You have learned something new today. You have understood new concepts. Maybe you have learned to do a sum in a particular way or in a different way. Also, after doing this lecture, do watch the video in which I have solved convergency questions from General Navigation Oxford book. Okay, do the questions from both these books. After this, it is also important to do the questions from Keith Williams. So also watch that video. Thank you for your time. All the best. Keep in touch with studies and keep learning and don't miss the next video. Be consistent. Thank you.